Hello, everyone, and welcome to Houston Techfest 2020, the virtual edition. Before we get started, I want to make you aware of a feature in the presentation that will make the session more interactive. Take note, in the upper right-hand corner of your screen, there's a question mark icon. And if you click that icon, it'll allow you to post questions to the moderator, me, and I will be able to read those questions to our speaker at the appropriate time. We're also excited to let you know that Code Magazine is giving everyone a free subscription. If you want to follow the link that's posted in the Q&A section to be able to redeem that, you can. With further ado, we're excited to present Paul DiCarlo, a principal cloud developer at Microsoft and a professor for Bauer College. He will be sharing with us get to solutioning strategies and best practices when mapping designs from edge to cloud. Paul, take it away.
Thanks for the intro, Max. Again, it's a pleasure to be speaking here at the Houston Techfest 2020 in this distributed fashion, and I'm sure we have all grown accustomed to. Of course, would love to be there in person with all of you. This is a community that I know I've been attending for quite a few years. I've got the 2016 shirt. I think this might be the 10th Techfest that I've been lucky to be a part of, and I'm happy to be sharing with you today a presentation that is actually a introduction to a larger presentation that is also part of a series of presentations that we have dubbed the Internet of Things Event Learning Path. And of course, I'll give you links to all of those resources here, but hopefully this presentation will give you a nice taste of some of the interesting things that are coming out in terms of IoT development and sort of pushing the boundaries in terms of what we can accomplish today with technology. So with that said, we'll go ahead and get started with Get to Solutioning, Strategy and Best Practices when Mapping Designs from Edge to Cloud. So in this session, we're going to cover, in the short time that we have, strategies for secure IoT device connectivity in real-world edge environments. In addition, we'll look at a common IoT solution architecture and show how that can be relevant to really any line of business. And finally, we'll cinch this up with a technique for implementing artificial intelligence at the edge to support an intelligent video analytics solution. And yes, we're going to somehow fit that in the 30 minutes of time that we have. So we're going to get started by addressing really the biggest elephant in the room from those topics when it comes to Internet of Things solutions. And that is, of course, the concept of security. So how exactly do we enforce security in solutions that typically require the use of sensors in the real world, potentially in publicly accessible areas? And as you might expect, it all begins at the device, but we must also address it in areas like the communication layer, in addition to the cloud hosting environment itself if one is employed. So we're going to go ahead and take a quick look at an overview of how Microsoft provides security for IoT solutions in each of those areas. So security concerns as they relate to IoT is a very real thing. In fact, if you recall, around the last election period in 2016, the Mirai botnet attack occurred, which involved 100,000 IoT devices that were taken over by hackers and turned into a botnet. That botnet was then used to launch a distributed denial of service attack, of which caused the entire East Coast of the United States to go offline for approximately a day, meaning no Netflix, no chatting, no online shopping. Now, if you think that's crazy, imagine hackers getting access to your corporate data by way of a fish tank. That sounds pretty unbelievable, but this actually happened recently to a big casino in Las Vegas where the attackers used a vulnerability in an aquarium thermometer to gain a foothold into the network. And once they were there, they were able to retrieve the high roller database and use it to their advantage. Now, these commercial systems and just regular end users being affected by this is big, but also industrial systems have seen these types of attacks as well. For example, in the recent Triton malware attack, hackers intended to manipulate layers of built-in emergency shutdown protocols that would be keeping a plant system running, and they fortunately were able to trigger an emergency shutdown system during that attack, which allowed it to be noticed and mitigated. But as you can see, if a system like this can be attacked, you can just think of the amount of damage that can be done if security is not taken into account during the development of these types of solutions. So as we've discussed here, security in IoT solutions is paramount. And as we noted, IoT always implies really the presence of devices, often with access to things like mission critical controls, sensor data, and potentially access to real-time video in computer vision-based AI at the edge scenarios. And of course, securing these solutions requires mitigation across all of the relevant data pathways, beginning with the device itself, its communication layer to whatever services it might be talking to, which could involve a cloud-hosted environment, and of course, the cloud environment itself. And of course, Microsoft IoT services take security into account in all of these layers, beginning with the device, the pathway to the cloud, and within the Azure cloud endpoint. Now, whether you're employing an IoT edge-based solution or a microcontroller-based approach with, say, a device like the Azure Sphere, the Azure IoT security architecture can allow you to monitor beginning at that device level and provide dashboards for monitoring the security state across all device workloads from within something we call the Azure Security Center. And what's nice is this integration is built directly into Azure IoT device connectivity SDKs, our IoT Edge runtime, and into the silicon itself in the case of Azure Sphere. So when you're building your solutions with Microsoft SDKs, services, and hardware, it means that security integration is available to your solution right from the start. And within the Azure cloud itself, you can rely on security and disaster recovery options available in each of the 60+ available global data centers. And this availability assures that no matter where your devices are in the world, you can expect low latency connectivity and throughput with the ability to enable things like multi-region failover protection to ensure that your IoT solutions are always up and running. And your security teams can also benefit from this protection because you'll be using the same security that Azure employs itself across its own data centers. And of course, if your solution requires industry compliance standards, we are ready to welcome you with regularly updated selections that currently consist of 93 compliance offerings. In the follow-up presentation that we'll link to at the end of this talk, we'll go into more details on approaches that can allow you to adapt Azure IoT solutions to accommodate various network environments in a secure manner. For example, if you have legacy devices that are not capable of running those secure device SDKs or the Azure IoT Edge runtime, we can still ensure security across the communication layer by use of something called the Azure IoT Edge Gateway. And this offering allows for a variety of configurations that can aid in adapting to the types of environments that may exist within manufacturing facilities, offshore intermittent remote environments, and even air-gapped internal networks with no outbound internet access. So we'll examine these configuration strategies and those environments that they're best suited for in depth in that follow-up presentation. So now that we've explained from a high level how IoT solutions built on Microsoft SDKs and cloud services can ensure security within even the most challenging network environments, we can begin the conversation on how Azure IoT solutions might be relevant to your line of business and what those solutions would look like from an architectural perspective. So recent innovations have allowed for the proliferation of IoT solutions across numerous industries, and it's no surprise that much of this innovation has been iterative, beginning with the availability of nearly limitless compute and storage via the cloud revolution. This has allowed for vast expansion in the ability to be able to operate and process data transmitted by devices at scale. We're now beginning to see the full circle effects of this as computing power is increasing to support and unlock new possibilities for small form factor edge devices, to the point that it's now possible to run accelerated AI workloads on devices that are not much larger than a cell phone. And as these innovations in cloud increase, we again see additional benefits. For example, with the adoption of Azure Digital Twins, it's now possible to replicate your physical environment into virtual space, allowing for a one-to-one mapping of real-world environments to the cloud. We refer to this paradigm as digital transformation and see the potential of Internet of Things and AI at the Edge solutions as the harbinger of mainstream AI. It's no longer a field that's riddled with complexity and cost. In fact, it's actually more available than ever before, with a learning curve that invites all who possess the interest to get started with it. And we hope that we can inspire you in this talk to get your line of business to perhaps investigate the benefits of these types of solutions where they can make the most impact to your processes and customer experiences. So the cross-industry relevance of these solutions pervades really any industry that can benefit from increased value, reduced waste, or enhanced procedures via the introduction of real-time insights and automated systems that react to those insights. For example, in recent times, many businesses are facing the effects of return to work in the face of the global COVID-19 outbreak and have a need to ensure the safety of employees and customers. And of course, you might have seen this in your own environments where automated systems now are screening and reporting visitors' well-being, as well as demonstrating the ability to mitigate the effects of that contagious infection using technically IoT-based solutions. And this is also extrapolated to the medical community, where we're seeing patients being monitored in real time, which allows us to get information during times of surge capacity, and also helping to assess and properly put patients who are under quarantine, and of course extending this to additional scenarios like blood sugar monitors and of course telemedicine in general. A common one that we're all familiar with is that futuristic vision of self-driving vehicles, which is at its heart an IoT solution, one that very clearly demonstrates just how fast insights can be enacted upon, to the point that vehicles can recognize potentially catastrophic events in real time. And this same system can again be extended to things like smart factories to reduce downtime, to automate quality control systems for increased production and reduction in deficits. And as we've seen here in Houston, energy companies can leverage IoT data to do things like adapt to demand spikes by recognizing them as they occur, and can even provide value to customers by using this data to automatically dial down the HVAC systems, perhaps even in our own homes, if you subscribe to that data yourself. And even in things like retail areas, it's possible to gauge customer behavior with a fidelity that mirrors or even exceeds that of online analytics, ultimately allowing for enhanced customer experiences by reducing shelf vacancy, optimizing reorder frequency, and of course the potential to offer product suggestions to customers within a store environment. So as you've seen, IoT solutions can address really a variety of different use cases, but it's interesting to note that in all of these examples, the pathway from the device to the cloud and to the line of business application is very much similar. There are of course variations of the specific technologies involved when encountering these solutions in the real world, but the workflow of using things or devices to capture and produce insights which lead to action is common to all IoT solutions. And once you understand this fundamental concept, you can apply it to a host of business scenarios to create relevant IoT solutions that make use of real-time insights. And extending this concept a bit further, we can produce a common architecture for IoT solutions built on Microsoft Azure by employing service offerings designed specifically to address this common workflow. Our things are really just IoT devices that communicate using those secure Azure IoT device SDKs, either directly to an IoT hub in the Azure cloud or by means of an on-premise IoT edge gateway. And once that data arrives to the cloud, we can begin to process and operate on the insights contained within using services like Stream Analytics to filter relevant information while your data is in flight. This allows us to extract time-critical insights into things like warm path storage for immediate use or offloading into cold storage systems for archival purposes. Once our data is in the cloud, scalable integration of that data into line of business applications enables the ability to take action on the data produced by our devices. So what exactly do these solutions look like in practice? We've talked about a few of these concepts theoretically, and now we want to show you how you can develop state-of-the-art AI at the edge solutions using the latest concepts in computer vision. And to demonstrate this, we're going to explore a real-world project that was developed using NVIDIA embedded hardware and Azure IoT services to produce a generic solution that can consume multiple video sources to produce insights at the edge using a custom object detection model. Specifically, we're going to look at here is the development of a solution that targets the NVIDIA Jetson hardware, which contains an onboard GPU for accelerated AI inferencing. We're going to provide full instructions at the end of this presentation that can enable you to replicate the solution for yourself, in addition to pointing out areas of customization so that you can modify it to detect really any object that you train it to, and demonstrate how you can integrate that into a variety of services provided in Azure. These will include things like the ability to visualize data using services like Time Series Insights and Power BI, as well as going deep into the differences between running stream analytic workloads on devices at the edge, in addition to running those workloads in the cloud. Now, because this solution is built on Microsoft Azure, it is naturally aligned to the Azure IoT reference architecture that we previously discussed. And our IoT edge device is going to essentially allow us to be able to pull down a custom object detection model that we're going to build using cognitive services, and then couple that with a streaming analytics module that will run on the device to filter those results before they get sent to the cloud. This allows us to have a super filter that allows us to essentially get only the data that we need and then report it into our line of business applications, which in this case will be services like time series insights and Power BI for reporting. But in addition to this, we're also going to support concepts like ML ops, for example, by using something called a camera tagging module that will allow us to capture samples to train our object detection model directly from the device while it's deployed in the end user environment. And these can later be used to enhance our object detection model even better, which we can then update our model down at the edge by submitting a deployment through the cloud. So what we're going to go ahead and do is start by playing back a demonstration of this solution in action. The following demo is, of course, available online and consists of not only the steps to reproduce, but 8 hours of live stream content showing how to build this from every single step of the way so that you can replicate this for yourself. So let's go ahead and get started.
The following demo, Intelligent Video Analytics with NVIDIA Jetson and Microsoft Azure, is available on GitHub at aka.ms/iot50/intelligent video. This project can be reused for learning or may be re-implemented as a baseline for your own custom solutions. Let's get started. So right now, you're looking at a live feed of 4 simultaneous camera feeds that's also performing object detection inference in real time, utilizing a model that was created in Custom Vision AI. Now, this model is capable of detecting vehicles, people, as well as some of the pets that can be found around the home. And we're going to show you how you can take this solution and connect it with services in Microsoft Azure, for example, things like time series insights or Microsoft Power BI, to be able to view telemetry from your devices in near real time. We'll start by checking out the services that make this up by looking at the resource group for our Intelligent Video Analytics solution. And you might be surprised to notice that there's really only 6 services employed here, and technically one of them is really just a connector for one of the other services. Let's go ahead and revisit our architecture diagram that we were looking at previously in the presentation. The way the solution begins is that we have a device, specifically an NVIDIA Jetson device, that's running something called the NVIDIA DeepStream SDK as an IoT Edge module. And this is because NVIDIA publishes the DeepStream SDK as a module in our Azure Marketplace. You can go ahead and pull this down, configure it, point it at camera feeds, and then supply it with, in our case, a custom vision AI model to be able to perform inferencing in real time on your device and push those results into Azure IoT services. Once we get telemetry from that module, we then forward it to a streaming analytics job that's actually going to run on the device. And this will essentially act as a super filter because the telemetry is going to be coming at us very, very fast. In fact, if you look at our live feed, that box, the reason why you're not seeing it go away is because it's producing results that fast. Once we get our summarized results from that stream analytics job, those will then flow into our IoT Hub. And this means we're not going to inundate it with every single detection, only the ones that matter the most to us. And we can tune that by modifying the stream analytics job down at the edge. Once the data appears in IoT Hub, we can then take all telemetry flowing through it and forward it into a time series insights event connector, where we can then visualize it in time series insights. Similarly, we can also take that same telemetry and forward it to a stream analytics job that's running in the cloud, and then forward that to a Power BI report. And of course, all of this is surrounded by our custom object detection model that's deployed down to our device and leveraged by that DeepStream SDK module. Now, the part that we're going to start off with is how we're actually going to train that model utilizing a service that runs on the device that will allow us to capture samples and then forward those either to Azure Storage or directly into Custom Vision AI where they can be used for training. Let's take a quick look at the IoT Hub before we jump into that. Here you'll see the IoT Hub that backs our solution, and inside here we can see that registered IoT Edge device. If we click on the device, you can see the deployment that has been applied. You'll notice that there's 6 modules that are currently employed. There's the Edge Agent and Edge Hub, which are system modules that are part of the IoT Edge runtime, in addition to 4 custom modules. The first one that we're going to look at here is the camera tagging module. And this is what's going to allow us to obtain samples to train our object detection algorithm, utilizing samples captured directly from the environment. So if we visit port 3000 on our IoT Edge device, you'll notice here that we're presented with that camera capture module. And there's an interface here that allows you to specify a camera feed that you'd like to connect to. And from there, you can go ahead and capture samples. So in this case, I'm going to go ahead and tag this one car. And we'll give it a name, test 002, and we'll go ahead and save it. Now, once we've saved that image, you'll see it comprised with a number of other images that we gathered earlier. And from here, we can either choose to upload those images directly into blob storage or into custom vision AI. And this is rather straightforward. For example, if I want to push these into blob storage, you can either push to local, and this is useful for environments that don't have outbound internet access, and this will store those images locally, or we can push directly to a blob in Microsoft Azure. I'm going to go ahead and demonstrate pushing this directly to custom vision. Simply provide my endpoint, my training key, and then I can choose the project that I want to apply it to and select push, and it's that easy. My new training samples are now part of my custom vision AI project. Now, when I gathered all the samples that you're seeing here, I actually gathered quite a few. I think it was 4,000 or so over a weekend. And I actually stored all of those into Microsoft Azure Storage. Now, that's an option that you can enable in this demo, and we won't cover that. But it's interesting to point out here that your data can arrive either in this cold storage area or directly in the custom vision AI where it can be utilized. From here, I gather a number of different samples taken at different times of day, also in different environment conditions. And this allows me to do things like be able to detect things at night as well as in the day. Once we've got enough samples, we can go ahead and train up our model and again, export that for use on our IoT device. Now, specifically what we're employing here is the Onyx model format. So once I've exported that, I can then configure that DeepStream module to leverage it, pick it up and use it, and it'll begin detecting the objects that our model has been trained to detect. For more details on this, I'm going to include a resource at the end of our presentation that goes into a full deep dive on the Azure IoT Edge camera tagging module. Now, once we get that model up and running with the DeepStream SDK, it becomes important to filter those results because, again, they're flowing at us extremely fast. And the way we're going to do that is by using a stream analytics job that we deploy down to the edge. And it's interesting to note how this works. Here I've created a stream analytics query, and I can go ahead and set it up to work with a storage account, just like the one we saw a moment ago. I'm going to go ahead and create a new storage container called DeepStream Analytics, and here I can publish my actual job. And what this means is that our IoT Edge module will pull the job down from Azure and then run it locally on the device. Now, similarly, there's also another stream analytics job that we alluded to earlier. And this one's going to allow us to forward our data into Power BI. There's a slight difference here. This particular stream analytics job lives in the cloud. So it's actually taking that telemetry from the IoT Hub and then forwarding it into Power BI. And the way that it's accomplishing that, if we head to the output, there's a specific type of output that you can choose. In fact, Power BI is just one of many. You can go to an event hub, SQL database, data lake storage, table storage, service bus topic queue, Cosmos DB, Azure Function, or Azure Synapse. And once we've got our data forwarded over there, we can begin to make use of it with Power BI reports, which we'll look at in just a moment. But first, we're going to show a quick software as a service offering known as Time Series Insights. And this is just one of the many visualization tools that you can use in Microsoft Azure. Once we forward that data over, the only thing that we have to do is model it by specifying a custom type. And once we do that, we can start to graph all of that telemetry through custom hierarchies that we've defined and know when we've detected various different objects throughout the home or when I've seen people specifically, or perhaps vehicles in the yard. So let's go ahead and head back to that Power BI demonstration. So imagine that we have a custom Power BI report that we created in Power BI Desktop. We can publish that report into the cloud. It's very straightforward to do that. And once you've done it, you can go ahead and begin to see your results within your Office 365 subscription. So I've already gone ahead and done that here. By choosing my workspace, we'll select that and we'll go ahead and push it up. And once that goes into Power BI in the Microsoft Office 365 offering, I can then view that report or perhaps share it out with other individuals on the team. And this is great because I can easily see things at a glance. For example, what kind of detections have happened at the home? Or perhaps, when's the last time that you saw people? From here, we can go ahead and take this report and we can pin it to a live page. And once you've done that, you can start to view the telemetry coming off of your devices in real time. In fact, a vehicle just drove by, and we can see here that our number of cars in the street is incremented to 1. And similarly, if I was able to see some people, we'd see this graph start to light up with results. And we've also got some telemetry here that shows us some interesting things like the last time and place that the dog and cat were seen. Now, if you like this demonstration, we actually show you how to build this from the ground up using live streamed videos that show us building the entire solution from scratch. So if you want to follow along with this, you can head to the GitHub repo for the Intelligent Video Analytics with NVIDIA Jetson and Microsoft Azure project. And you can watch those videos to discover this project, what it's like to build it for yourself, and hopefully learn all the skills needed in order to create your own custom intelligent video application.
So again, all of the resources that you saw are available online, and it's our hope that you can pick those up for reuse, either for a custom project or just for your own learning. Now, if you do go through that content, you will be ready to apply the Azure IoT reference architecture to create your own custom intelligent video analytics solutions. And these can be used to address a variety of use cases. In fact, really anything that you can think of. For example, by modifying the type of object being detected and ensuring that you are capturing data relevant to your business, you can put Azure IoT solutions to work in almost any industry, as we discussed earlier. Microsoft's own Project 15 project was born from this approach, producing a solution that assists in the conservation and protection of the world's elephant population by adapting the object detection model to detect, you guessed it, elephants, and updating the business integration component to visualize where they have been seen on an interactive map. You can learn more about Project 15 by heading to aka.ms/project15. For links to relevant documentation, resources, and demos used in this presentation, you can check out aka.ms/IoT50/resources. And if you're interested in using any portions of this presentation, for example, the slides or even pre-recorded videos of this session and the longer deep dive session, they're all available online at aka.ms/IoT50. And if you enjoyed this session and are perhaps interested in other topics that are covered in the IoT learning path, you can find them all on GitHub at aka.ms/IoTLP. Now, we've covered quite a few topics in this session, and I'd like to share that we've also curated a custom collection of modules that were taken from the Microsoft Learn platform, which pertain to all of the topics discussed in this session. And this will allow you to interactively learn how to securely connect your IoT devices to the cloud via the use of the IoT Edge Gateway that we alluded to earlier, how to build intelligent edge applications on the edge using Azure IoT Edge, creating solutions using the Software as a Service Azure IoT Central offering, in addition to how to leverage stream analytics in both the cloud and on the edge. And additionally, that learned content and the content in this presentation can also be used to help you gain an official accreditation that can help you stand out as a certified Microsoft Azure IoT developer. And if you are interested in that path, we recommend checking out the AZ220 certification. You can find more details on the topics covered and schedule an exam today at aka.ms/IoT50/certification. However, if IoT is not your interest, but you just want to learn about something new and cutting edge, we would recommend to head over to microsoft.com.learn, where you can begin to create your own custom learning paths using resources on the latest topics and trends in technology. I'd like to thank you again for attending this keynote session for Houston Techfest 2020, and we'll go ahead and open it up for question and answer.
Awesome, Paul. Thank you. I know that we're also up on our time box for anybody that needs to jump. We understand, but I think Paul mentioned that he's going to stick around a little bit longer for us to take a couple of questions. And so one of the questions that that came through, Paul, is Power BI the only technology you can use to model this?
No. So even in the demo, we showed a couple ways to do that with Power BI in addition to time series insights. Really what happens is once your data gets into that IoT hub, you can really easily forward it off to, I think there was a number of services that we showed in the demo there that included things like SQL database, Azure Synapse, in addition to topics and queues. Really, you can model it over to anywhere that you please. One of the nice things about Power BI that I find is you can create these interactive reports essentially without having to think about anything. I literally drag and drop the things until I get what I want it to look like. And most of the times, 99 times out of 100, it works for me.
Awesome. So another one that came through too is what tools do you recommend for local development with IoT?
So number one, first and foremost, I prefer using Visual Studio Code, and that's really for any development. One of the nice things about it is that it does have built-in hooks for performing things like deployments down to devices that are running IoT Edge, as well as being able to do things like monitor the data that's flowing through your IoT hub. So it gives you kind of a direct line of being able to visualize not only the path to the device, but also being able to do that monitoring of what kind of data is actually coming off of those devices in your cloud solution to give you that holistic view. And really, because of that, I almost don't use anything else except maybe like a text editor, depending on what it is that I'm trying to accomplish, because all the tools really are right there for you within the VS Code IDE.
Awesome, thank you. Another question was, what role or roles do you see blockchain technology having in edge to cloud solutions?
I think blockchain just at its core is really another storage mechanism. So if you were wanting to have some sort of unchangeable record of data that's coming off of your devices, which very much could be important in areas like, think food safety or anything really where data doesn't need to be tampered. I guess you could say most data is like that. It can allow you to do that, although do be aware that blockchain does enforce additional overhead to give you those features, and sometimes that overhead can come at a performance hit as opposed to using a standard database or perhaps something like a NoSQL backend for performance reasons.
Awesome. So this one kind of goes along, I guess, a little bit with that. They wrote, I see more and more of these trials are becoming costly as opposed to earlier, mostly free to try. So what is the cost involved in setting up this video analytics system for fun?
Great question. So the biggest cost is actually that stream analytics job in the cloud. If you can remove that, it becomes very, very cheap. And what I mean by that is running the stream analytics job on the edge is $1 per device per month. So that's just a given, really, really cheap. However, running the stream analytics job in the cloud is closer to like $20, I want to say, per month, but you only run a single instance of that, and that can facilitate multiple devices. So if you're trying to learn, definitely with an Azure free trial subscription, which will give you $200 in credit, it should be more than enough to set up these resources, because the majority of them, and in fact, we cover this in that GitHub repo, the majority of them can be supplied using free offerings within Azure. For example, the IoT Hub, we do have a free offering that allows you, I want to say 4,000 or 10,000 messages per day that you can employ here. That's really going to give you the same sort of benefits, unless you're perhaps using a multitude of devices. You might need to scale that up to a paid offering. But I'll give you a ballpark. It's around maybe $40 per month to implement this entire solution on your own. It might even be less. I'd have to double check on that.
Great. So this will be our final question, Paul. And somebody wrote, I'm not sure if everyone watching this knows what hot, cold, and warm paths are. Maybe you could enlighten some of the attendees.
Sure. Yeah. So that is the terms that we throw around is something called Lambda Architecture, which when you hear that really is nothing more than a service that has hot and cold paths. Now, what those paths mean is hot data is generally, or the hot path is generally data that needs to be accessed in almost real time. So it's going to be essentially cached up and ready to go for you. So if you're wanting to do live reports, you want that data going into a warm path system so that that data can be retrieved very, very quickly. Now, cold path is more for sort of your archival sort of data, or if you want to think about maybe you're capturing samples to train an ML model, that would go into your cold storage because it's not like you need to access that all the time, nor is it necessarily mission critical to the moment. So there's a severe cost savings benefit as well when you look at the two. So as you might imagine, cold storage services are often much cheaper than what you would see on the warm path side, just due to the resources that are involved that make that data available to you faster on the hot path side versus the cold path side.
Awesome. Well, I want to thank everybody for attending today, and Paul, thank you for sharing and being here. I did post the link to that 8-hour video that Paul brought up into the chat, so if you guys wanted to pull it down from there. And just a reminder, this session's being recorded, and it'll be up on the Houston Tech Fest website soon. So if you do want to get back to some of the links that Paul was talking about, it'll definitely be up there, and you can go back through the recording. We hope that you guys have a great rest of your day and enjoy the rest of Houston Tech Fest. Thanks again, Paul.
Thank you, Max. It was a pleasure being here. And thank you, Michael. And thank you, everyone, for attending this Tech Fest. It's been a pleasure to be here with you all.